Hello, all this experiment we will study the kinetics. Okay, how fast of the chemical reaction with respect to the time. This one is not from your experimental textbook, but it's from the handout. I give you the handout, okay? Now in this handout, the general idea is we will study the glucose hydrolysis of the glucose or sucrose. Sucrose will react with the water, okay? From the glucose and the fructose. Now, it reacts with the water is called hydrolysis. Now, it's very, very slow. Now, we want to speed it up, so we add the catalyst, which is hydrochloric acid. So, we will add a different concentration of hydrochloric acid to speed it up. Then, we will monitor how quickly of this chemical reaction versus time. Now, before you do any lab, I wanted to remind you, first, go to your handout, go to the page 7. It says the solution concentration. Your concentration of HCl, here the concentration is too low, so we cannot see it clearly during our lab time. So I suggest you to change this one, change 4 molarity to 8 molarity, 2 molarity to 6 molarity, 1 molarity to 4 molarity. So change this concentration to 864. That is the first. Now you need to prepare these solutions based on your general chemistry or analytical chemistry. Use M1V1 equals M2V2. Use the concentrated HCl, which is 12 molarity. You need to calculate how much you need and how much you need to put into the water to make that 8 molarity. Then dilute that from the 8 molarity to the 6 molarity and 4 molarity for your lab use, okay? This is the first part. The instrument we will use is this one. It's called polarimeter, okay? So what is the general idea? What is the physical background of this one? The physical background, let me explain this one to you. So your sucrose, glucose, or fructose, all of them are chiral molecule. You know what a chiral molecule, right? It's just like your right hand and left hand. So your molecules are composed by exactly atom, but their structure are different. So the molecules cannot overlap. So this is called a chiral molecule, like your hand. Now chiral molecule has a property, so when the light shoots this one, it will interact with light differently. Because this light rotate a little bit. Then what do we mean the light rotate? What is the light? Light basically is electromagnetic wave, just like your cell phone, iPhone electromagnetic wave. What is the electromagnetic wave? Basically electromagnetic wave like your hand, like this one, okay? So when you use these fingers 90 degrees from each other, looks like Z direction, X direction, Y direction. Now this is your light shooting in. So your signal goes to this direction. Now what is the light? The light basically is the electric field vibrating along this direction and accompanied by magnetic field vibrating along this direction. They are 90 degrees perpendicular to each other. Both of them perpendicular to your light directions, okay? So normally our light source, the regular light source, so their vibration is completely random. That means if you get the light goes this direction, some of them are vibrating this direction, some of them are vibrating this direction. So they are completely random, okay? So this one is called regular light, natural light. Now in the instrument, a lot of time we are more care of electron vibration, because electron field vibration directly affects the electrons in your molecules. So very sensitive. The magnetic vibration is not very sensitive. So we are not care the magnetic very much. We just care the electric field vibration. Now, if we forget the magnetic field, that becomes just 2, right? This one is your light shooting in this direction, this is electric field vibrating, okay? So now the natural light, the electric field vibrating in any direction. So if you shoot in the same direction, some of them vibrating here, some are vibrating here, some are vibrating here. So everywhere, every direction there is a vibration. Now there is a material called polarizer. When this one goes through a polarizer like your hand, okay, with the slit. Now you're vibrating different direction. After you go through this one, you can see only the vibration along this slit will pass through. All the rest will be blocked. Then you completely random before you reach this one. Then after you go through this one, only one direction vibrate. That is called polarized light. Okay. Now remember, the polarized light is just the vibration in one direction. Now when they interact with your molecules, okay, now your molecules, because the chiral molecules will interact with polarized light a little bit different. Okay, some of the molecules make this, okay, vibration direction switch a little bit to the left, clockwise. Some of the molecules will switch it a little bit to the right, counterclockwise. Okay, now when the sucrose hydrolysis become glucose and fructose, they are vibrating differently, change the vibration direction differently. Okay, now from stoichiometry and the vibration direction change, we can tell how fast of your chemical reaction. Basically, we just measure your light, vibration angle, polarized angle before reach the sample, okay, and after reach the sample, what is the angle difference? So this angle difference here, so that is our measurement. Now this angle difference depends on your concentration, and then they will change with the time. From this angle difference, we plus the stoichiometry, we can find the concentration change of your sucrose, sucrose, how they decay with the time. That is your experiment. Now that is a general idea. Your instrument will use this instrument. This instrument, you can see, we will use just one single light. So this light, we will filter this light. So this light, we use a filter. So filter, this is a single wavelength, so that is a single color, monochromatic. Okay, so this wavelength is 589. So this one exactly as the sodium light. Okay, sodium light is 189. Okay, so that means the regular light passes. This is the light source, the tungsten light source. We direct it here, pass this one, just the yellow light goes through this one, sodium light goes through this one. Then here is a polarizer, because this one is a single color, but the vibration is any direction. So after the polarizer, the vibration just one direction. So this light shooting in this direction, the vibration in this direction. Okay, so now let's go through these chemicals. Now suppose we put your chemicals here. Okay, so you can see these two ends are a little bit different. This end has a small cut. This end is just a round one. So this small cut will face the light in. Okay, so you will put this one here. Then the light goes through here. After they go through the chemicals, they will change the angle. They measure the relative angle change between before and after. Then they will send this signal to the computer to record the angle change. That is a general idea of this experiment. Okay. Now in this experiment, we will do two parts. The first one is how they change with respect to the concentration. The second one is how they change with respect to temperature. There is a temperature sensor here, and this compartment, we can change the temperature a little bit, heat up a little bit. Okay. So the temperature sensor, we put it inside. So when you cover this one, we can, okay, so we can heat up a little bit. We can use a computer to control this one. Okay, now this is a general idea. Now let's tell you how to do this experiment. Now this is the chemicals you will use. Okay, so this is the sucrose, and this one is 8 molarity of HCl. Okay, so we will mix these two. So each of them will exactly the same amount. Okay, so let's say this is 10 ml of sucrose, 10 ml of 8 molarity HCl. So you put this one here. Okay, so measure this one inside of this graduate cylinder. So this one is the circles. Okay, both of them are exactly, okay, 10 mil. Okay, now I will mix this one, dump this one into this beaker and shake it. Okay, shake it, then they starting to quickly react. So after they put this react, then I dump this one into this cell. Okay, put this cell here. Then we will use a computer to monitor this one. Now let's make the computer ready. Then before you mix them, okay, let's put this one aside. Now the program control this one is inside of this computer. I will introduce a little bit. Let's close this one. Now program is on your right top. This is called the spectrum manager. So you double click this one. Okay. Now double click this one. You will open the manager, the program. Now in this program, you click the first one, standard measurement. Okay, so you double click it. It will need you to initiate your machine. Okay, now machine is initiate. So normally it says they need some time to heat your light source, tungsten light source. It's about 1 minute. You just wait for it. Then it will pop out this window. Okay. Now this window here is things I wanted to show you guys. This one is a parameter. Okay. This is the temperature. You can see, you can play with this one. Okay. Now this is a parameter. You can come here to see the parameter, but you can see here is a parameter also. So this is, first one is the series of this machine. Second one is the light source. We use a tungsten. The filter, you must match this one. We said this one is 589. So that one is also 589. You don't need to change anything. Now the sample compartment, we close this one. Okay. Now the aperture, the size of the small hole you need your light go through. We don't worry about this one. That is 8 millimeter. So sub aperture small, aperture large. So analyzer, we use stop this way. We use a PMT tube. Okay. To stop this one, the parameter. Let me see. Can I bring the parameter out to tell you what it means? Okay. So let's say measurement. Go to the measurement. I click the parameter. All the parameter is here. So let me tell you what it means. Okay, this is relatively important to us. We just needed to know the general idea. You can see here is a light source, it's a tungsten. So wavelength is 589. That's a DIT, duration of the measurement, 5 seconds. What does that mean? That means each time they measure 5 seconds, the light keeps shining on 5 seconds because they want to average to get the best signal noise, okay, ratio. So the cycle time, that is 100. Basically, that is just 100 points, okay? I ask you guys to set 100 points because you might not need 100 points. For example, if your reaction is quickly going down there, quickly reach the plateau, you can stop it at 40. Okay, but we leave it at 100 maximum because after 100 it automatically stopped. So if you leave it too short, it might automatically stop before they reach the plateau. So we need we leave the 100 point here. Okay, now here is a cycle interval is 60 seconds. That's 1 minute. What does that mean? That means you measure 5 seconds, then wait for 1 minute, then measure another 5 seconds, then wait for 1 minute. Okay, that is a time interval between 2 points. So the temperature correction is at 20 degrees. This one is the cell. Now this everything is okay. Okay. So now everything is ready. So when you're starting to measure, you just click the sample. Okay. Then they will start to measure it. We don't need to do the background because we just care the relative value. We don't need to care the absolute value. Okay. So now everything is ready. Now you can see this one is the optical rotation. That is the data you wanted to know. That is the temperature. That is the optical rotation degree. So these two are exactly the same. Doesn't matter. This is the voltage of the PMT tube called photomultiplier tube. This one basically accepts your signal. If it is working correctly, this one should be several hundred volts. Okay. So now everything is ready. You just click this sample, they will starting to measure. Now let's show you how to do this one. Okay, before we start in sample, we need to open this guy. Okay. Now this two, we put it here. Okay. Now this is a beaker, so you want to put this one to measure this one inside the beaker. Now this one is a cell. This cell is quite expensive. Don't break this one. Okay. I suggest you leave this drawer open. In case you drop in the drawer, not the ground. Okay. When you do the experiment. Now the first one is you mix these two. So you just dump this one here. Then dump it here. Then shake for a while. Okay. Then add this one, hold the center, okay? Don't hold the side. So you add this one to your cell. You need to add this one all up to these two stages to make sure this one is completely filled, okay? Then here are two leads. Okay, here are the two leads. Now let's put this one inside of this one. Make sure this with the cutting edge face the front, and then this one is fixed with this fixer. Okay. So you can see everything is finished. Now we put everything here. Now we come here to measure it. Okay. So now it's very easy. We said it, just click this one, the sample. It will start to measure. It will ask you the sample name. You can put this one. So you can just ignore it because you will monitor it anyhow. Now just starting to measure. Okay. Now you can see they're starting to measure the sample now. You will see the data here. Okay. Now you can see the first data already coming out. Okay, the 101 is a positive 2 point something. That's optical rotation. Okay, now every 1 minute there is another sample, another data coming out. Now we just wait for another data coming out. You can see this is the first data. Okay, so the first one we don't worry about. This is exactly the same. Okay, that is just the initial point. Okay, so this is the second one. Okay, so first one, second one. Okay. So wait for a while. So this is the third one. You can saturate, it will keep going. Now you need to monitor this one, right? How do you know when it will finish? So easy. We just use Excel to plot it at the same time. Now let's see, we open the Excel, okay. You put your data, what is this? So now you plot your data right away, okay? So now, for example, this is Excel. So let's say this is 1, 0, 1, 2, 3, etc. Right? So that is your 1 minute, 0 minute, 1 minute, 2 minutes, 3 minutes. You can highlight, then go to this edge, get the cross, then drag it. It will automatically fill this one for you. Okay, then you will input your data here. Okay, your data, your first one is 2.2006. Okay, 2.2006. Okay, your second one is, your first one is 2.2006. Your second one is 2.1785. 2.1785. Your third one is 2.1606. 2.1606. Just check this one here. The fourth one is 2.1431. Okay, so now you try to plot this one to see when they reach the plateau, right? So you can highlight this one needed to be moved a little bit to the upwards because so we highlight, you can highlight a little bit extra because you see the overall change. Now you highlight this one, you come here to insert your graph, okay? You insert your scattering. So this is your data, okay? So you can see you keep decreasing, right? So you just keep changing, okay? Keep add this one on. It will plot, for example, the last one is 2.1289, 2.1289. So you enter this one in, that one, another one come out. So you can double click this line, delete this one. Okay? So you can see they keep changing until you see the plateau. Then you come here to stop it. Okay? That is your experiment. After you do this one, save this data. You need to simulate, use the computer simulation in the next room. Okay, it's a computer room. Now you can see just let them go. Okay, so after you finish this one, okay, this is your 8 molarity. Then you do the 4 molarity. You do the 6 molarity. So after you finish this one, you need to change the temperature. Okay, now let's say we stop this one. We change it at the different temperature. So control. So let's see the temperature change. This one is 24.85. Now let's see, we need to so this one is change the temperature control accessory. That is the temperature you want to change. But for this lab, we don't want you to do the temperature change for this semester. Next semester, we want to do the temperature change. Okay, so now let's see how to change the temperature here. So edit, control. So settings, okay. Now here is the temperature setting. So let's say apply. control. So this one we cannot change the temperature now. So we don't do the temperature change for this lab, okay? So for the time being. So this is the lab for the kinetics. You just do the different, for the different concentration. Then after we get this data, we'll simulate this one with a collector graph, the program. Then we'll finish this lab, okay?